In this lesson, we'll be doing question 3 of November 2023. So, they said given the geometric series 3 plus 6 plus 12 and that is to n terms. So 3.1.1 says write down the general term. General term simply means Tn. So Tn of a geometric sequence is given as ar to the power of n minus 1. So what is a? A is the first term in the given series, that is 3. And what is the ratio? The ratio is equal to T2 over T1 and is also equal to T3 over T2. So what is T2? T2 is 6 over 3 is equal to 12 over 6. And if we do that, we will get 2. This means that our ratio is equal to 2. And we can say that, therefore, the general term is given as Tn is equal to A, which is 3, multiplied by 2 to the power of n minus 1. And that is the general term. I hope it is clear. So, we're going to move to the next question. It says, calculate the value of k such that we are given the sigma. So the sigma notation is given as follows. Here we have k. Here we are given k. This is k. And here we are given p is equal to 1. And the general term is 3 over 2 multiplied by 2 to the power of p. And they say that is equal to 98301. Let's move this to the side. It's 98301. So we've done a similar question to this. We said that this thing here, all of this stands for the sum. And they said that the sum is equal to this. This means that we are given the sum. So we can go further and write the sum. We can say that Sn is equal to 98301. So that is the sum. And then we're going to determine the first 3 terms. We're going to determine the first 3 terms. We're going to say that, okay, so if we can check here, we don't have to go any further to calculate the 3 terms. The 3 terms are given here. The sigma here represents the sum which was given there. Okay, do you understand it? So 3.1.2 is a sub question that arises from 3.1. So the first 3 terms are given. So what we can do, we can determine the number of terms. N is equal to top minus bottom plus 1. So what is the top? The top is given as k. The bottom is minus 1 plus 1 and we get k. This means that n is equal to k. Okay, this one is easier to solve. But it's geometric. We can write the formula for the sum of a geometric series. Let's do it. We're going to say that, let's erase here. So the formula is given as Sn is equal to A multiplied by r to the power of n minus 1 divided by r minus 1. They say that the sum is given as 98301. So we're going to say that the sum is 98301 is equal to A. A is the first term in the series which was given, which is 3, multiplied by the ratio, which is 2 to the power of, we said that n is equal to k. We are solving for k. Where we see n, we're going to plug k. Then this is minus 1 all over ratio, which is 2 minus 1. So let's see. Here we have 98301 is equal to 3 multiplied by 2 to the power of k minus 1 over 1. We can just leave it because over 1 does no difference. So what's next? We're going to divide both sides by 3. We divide both sides by 3. And if we divide 98301 by 3, we get 32767. That is 32767 is equal to 2 to the power of k minus 1. So we're going to transpose the minus 1 to the left side. And we're going to have 32767 plus 1 is equal to 2 to the power of k. So we're going to add 1 here, and the answer will be 3, 2, 7, 6, 8 is equal to 2 to the power of k. Remember, this one will be the left side, this one will be the base, and this one will be the number. Okay, this one will be the number. So we're going to use logs because the exponent which we are looking for is given on the exponents. So we're going to say that the left side is k. We're going to say that k is equal to the logarithm base 2. The number is 3, 2, 7, 6, 8. So at the end, we can say that k is equal to, let's see, it's log base 2, 3, 2, 7, 6, 8, and the answer is 15. This means that k is equal to 15. I hope it is visible. So, because we say that the number of terms is equal to k, and k is equal to 15, this means that the number of terms in this case are equal to 15. Okay, I hope it is clear to everyone. Let's move to the next slide. So, here we are given a word problem. They said that a geometric sequence and an arithmetic sequence have the same first term. The common ratio of a geometric sequence is 1 over 3. The common difference of an arithmetic sequence is 3. The sum of the 22 terms of an arithmetic sequence is 734 more than the sum to infinity of a geometric sequence. Okay, so we are dealing with two parts here. We have a geometric, and we have an arithmetic. And we are given the properties. We are given an arithmetic here. They said that the term number 1 are the same for everything, for geometric and arithmetic. So we can say that T1 is equal to A. Even this side we can say that T1 is equal to A. And they said that the common difference of an arithmetic, the common difference is equal to 3. And here the common ratio is equal to 1 over 3. Then the sum of the 22 terms of an arithmetic sequence is 734 more than the sum to infinity of a geometric sequence. This means that if the sum of the first 22 terms of a geometric is given as x, therefore the sum of the 22 terms of an arithmetic sequence is given as x plus 734. They mean that an arithmetic part has 734 terms more than the geometric part. I hope you understand this. So the word more than simply means sum, the addition. So we're going to work the two separately. We're going to start by calculating the sum of a geometric, and then we're going to calculate the sum of an arithmetic, and we're going to solve for x and a simultaneously. So we can say that for a geometric, Sn is equal to a multiplied by r to the power of n minus 1 divided by r minus 1. Okay, I hope that is clear. So what is the sum of the 22 terms? That is equal to x, and we can say that a is equal to a. No problem there. The ratio is 1 over 3, and we said it's sum to 22 terms, so it's to the power of 22 minus 1 divided by 1 over 3 minus 1. So let's see if we can do all this. We're going to have x is equal to a multiplied by, let's plug all that we see in the brackets there in the calculator, 1 over 3 to the power of 22 minus 1, and you get minus 1. And then 1 minus 3, 1 over 3 minus 1 is given as minus 2 over 3. And then we're going to do the cross multiplication. By cross multiplying, we're going to say x multiplied by negative 2 over 3 is equal to negative 1 times a, which is negative a. So this is going to be negative 2x over 3 is equal to negative a. Remember, if we have a negative sign on both sides, we can divide both sides by a negative, meaning they cancel out the negative signs. And we can say that therefore a is equal to 2x divided by 3, and this is equation number 1. Okay, so we are now going to calculate the sum of an arithmetic to come with the second equation. So a sum of an arithmetic is given as the sum to n terms is equal to n over 2 multiplied by 2 times a plus n minus 1 multiplied by the constant difference between consecutive terms. So the sum to 22 terms is given as 734 plus x. So we're going to say that here we have x plus 734 is equal to 22 over 2, because that is n, multiplied by 2a plus 22 minus 1 times the difference, which is 3. Okay, so we're going to work this out. So here we can just say it's still x plus 734 is equal to 22 divided by 2, that is 11, multiplied by 2a plus, let's punch all this, 22 minus 1 times 3 on the calculator. 22 minus 1 multiplied by 3, that gives us 63. So this is plus 63. So we can multiply everything by 11, the one that is inside the brackets. Therefore, we'll have x plus 734 is equal to 11 times 2a, that is 22a, plus 63 times 11. Let's see, that gives us 693. So this is 693. So what we're going to do here is we're going to add the like terms. We can take the 693 to the left side and then it changes the sign. We'll have x plus 734 minus 693, that is equal to 22a. So what is 794? 734 minus 603, that gives us 41. So x plus 41 is equal to 22a, and that is equation number 2. So remember that if we are solving for simultaneous equation, let's take it from here. Where we see a, we're going to plug 2x over 3 in the second equation. So we can say that substitute equation number 1 in equation number 2. So we're going to say that x plus 41 is equal to 22. What is a? A is equal to 2x divided by 3. So here we have 2x divided by 3. Okay, I hope it is clear to everyone. So here we're going to say that x plus 41 is equal to 22 times 2x, this over 1. So this is going to be 44x over 3. Okay, 22 multiplied by 2 is given as 44. So here what we can do is to multiply every term by 3 to get rid of the denominator. So we can say we have x multiplied by 3 plus 41 multiplied by 3 is equal to 44x over 3 multiplied by 3. And this one cancels this one. What we have there is 3x plus 41 times 3. Let's see, 41 multiplied by 3 gives us 123 is equal to 44x. And we can write here, we can add the like terms. We're going to take the 3x to the right side and we're going to be left with 123 is equal to 44x. Okay, let's just subtract 44x minus 3x. What is 44 minus 3? That gives us 41. And this is 41x. And then we divide both sides by 41. Divide both sides by 41. This one cancels this one. And at the end, we have 123 divided by 41. And that gives us 3. Okay, can you see it? So x is equal to 3. Then we're going to use the simplest equation. They say that a is equal to 2x over 3. We know that a is equal to, let's erase here. So a is equal to 2x over 3. We can just write that here. That a is equal to 2x over 3. That's equation number 2. So when we see x, we're going to plug 3. We can say that a is equal to 2 multiplied by 3 divided by 3. And the 3 cancels the 3, and then our a is equal to 2. So remember that a is the first term. And the question said, calculate the first term. Oh, that is a lot of work. Calculate the value of the first term. There it is. So we have calculated it, and then we can say that our a is equal to 2. I hope you understand this. Make sure you are comfortable with the idea of solving weight problems.